Okay, so good afternoon, everyone. Welcome to the afternoon sessions. First of all, I would like to extend my appreciation to the Thailand Concrete Association for co-hosting this quite meaningful seminar. And also, many thanks to all of you who took time to participate. Today, I want to discuss a topic of post-tensioning durability. And I think this is a topic that's probably has not been well discussed in Thailand. And I want to talk about lesson learned, issues, and recommendations. Now, in the morning sessions, we have Professor Chakrampong, who talked about the durability of concrete, okay? And I think it's important to understand that the word pre-stressed concrete comprises a pre-stressing system and concrete. So while the professor talked about durability of concrete, I will talk about the other half, the post-tensioning durability. So since the invention of post-tensioning in the 1940s, there has been a pre-stressing structure built all over the world for about 80 years, and that's a lot of structure. But only in the last couple of decades that the issues of post-tensioning durability has surfaced around the world in Europe, in US, in Japan, and so on. And I think in Thailand, pre-stressed concrete bridges have been built over the last 40 years or so. So I want to discuss this with you about lessons learned from around the world on this issue. What are these issues and what are the reasons? What are the inspection methods, maintenance, and repair solution that's possible? And finally, a little bit recommendations on design and specification. Now, when we talk about these issues, I draw a comparison for health inspection. All right, so I think many of you are probably 40, 50 years old. Okay, I'm 52 myself. So since many years, the doctor has told me, hey, you're up to the age that you should get some health checkup. But I think a lot of owner has the same mentality as me. First of all, I don't want to know about it, maybe. Second is, I'm healthy, it will not happen to me, right? But as soon as you start to hear friends and family around you that the guy running marathon has high cholesterol, a friend of mine, this is real, playing basketball and had a heart attack, right? And your aunt and your uncle start to have cancers, problem this and that. And you start to tell yourself, hey, maybe I should have a look at myself, right? So I think this is a common mentality faces a lot of owners, right? And I started to making my health checkup now, right? So I think looking at lessons from friends and family around the world, and I hoped that's the key takeaway for today. It's not for you to go and rush and start making inspection project, but I think at least I want you to be aware of this, and I want you to have the curiosity of looking at this issue where it has happened around the world, okay? So a little bit by myself, besides I'm 52 years old. I started working for DWDAG after I graduated, so I've been around for 27 years. Most of my life I've been associated with pre-stressing structures. I also have built around 20 stay cables and different type of pre-stressing structure. I'm currently the Asian Regional Manager for DWDAG, in charge of around 12 countries in the regions. And it's an honor for me to be here and share this topic with you. So first, a little commercial time. I think DWDAG is well known in Thailand. Very long time ago, we were involved famous project like the Don Mueang Tollway, the Krung Thap Bridge. And I want to tell you a little bit about DWDAG as today. Okay, so we have a history of 150 years plus, about 159 to be exact. We have more than 300 products and services, and we have all around the world, more than 1,500 specialists, and we have an annual turnover of about 450 million euros. Our products is not just pre-stressing anymore. Besides pre-stressing and stay cable, we have a lot of product covering formwork accessory, geotechnics, tunneling, minings, and as well as a trendy new trend about smart monitoring solution, which my colleague Jacob will share with you in the next presentation. So here's a look at our product line: post-tensioning stay cable on bridges, on tanks. We have geotechnical and tunneling covering excavation work, slope stabilizations, as well as NATM tunneling methods, providing a lot of different tunneling support systems. And something relatively new for us, and I think it's also the point of this topic today, is lifespan management. So we have created officially a business unit on lifespan management, looking at inspections, maintenance, and highlighting the importance of this around the world to asset owner, to designers. And we also provide structural monitoring and digital twins solutions. And we also have developed a series of technology, which Jacob will share a little later, on how to deal with inspection, especially come to state cable projects. So in Asia, we are quite well represented, starting with 1958 in Japan. And today our friends from Japan, Sumitomo Electric, is here with us as a co-sponsor for the seminar. And throughout the next several decades, we are expanded all over the place. And SPAN System is our current local representative in Thailand. So let's look at the health problem of our families and friends around the world, starting with Europe and UK. So in 1985, this Innes-White Glass Bridge is actually a very famous case if you read through the literature. It suddenly collapsed in 1985 after 33 years. And this sort of instigated a whole awareness within UK on post-tensioning durability problem. And being as conservative as the British, they banned immediately grouting post-tensioning, right? Until they're able to come up with finding out the reasons, solutions to improve this. So it was banned in 1992, and they started a very thorough investigations on countrywide on pre-stressing bridges. So they took a sample of about 447 bridges, and they found 25% of them contain large voids or ungrouted tendons. 4% contain severe corrosion. So now 4% may not seem like a big number, but in a country where you have 50,000 bridges, 4% is 2,000 bridges, right? And I think it's the last thing that owner wants is one or two bridge collapse, right? So it is a serious issue. So UK took it very seriously, and in 1996 they published TR47, which is one of the first guidelines whose specific targeting on looking at this durability issue, and they identified new guidelines covering corrosion protection system for PT, as well as grouting material, testing procedures, and then detailed requirement for grout vent design. And I think throughout the presentation, you'll see I mention or refer to these topics quite often. So not only the first publication was done in 1986, subsequently new lesson learned, new technology, new ideas. So it was the TR47 was updated in 2001, and in 2020 it was updated again to TR47's new guidelines involving detensioning of external post-tensioning and regrouting. In rest of Europe, in Germany, it was found that about 50% of a bridge built in 1970 show corrosion damages. So also a very conservative approach by Germany. They also banned grouted tendons very quickly. And by 1999, they specified that external tendon has to be replaceable and restressable, okay? So once you find a damaged tendons, if you cannot replace it, then there's not much you can do, right? So from the design perspective, replaceable, restressable become a very important criteria. So nowadays, Germany only use non-grouted, prefabricated wax-filled external post-tensioning for all the bridges. Same thing in Italy. I will not, show a lot of cases, but things happen, collapse, serious corrosions. You can see that after the bridge collapse, they took out the tendon and found it to be extremely corroded. And unlike concrete, where durability problem you can see on the surface, you have crack, you have delaminations, and so on. The post-tensioning tendons are normally embedded inside, which you cannot see. France had its own case. Between 1994 and 2005, they found 5 cases of ruptured tendons in 5 bridges, which has only been around 15 years in service. And again, France banned cement grouted tendon since 2001, and only wax fillers is permitted. So this is what it looks like on ruptured tendons. The the tendon gets corroded to a certain stage and just snaps, opens, it's deformed, and this is what happened when you open up and you see these issues. And only the owners or the inspector probably will not see this, right? And it's always a case where you stumble upon, right? So what does Europe did after that? Besides UK, the FIB, which is the Pre-Stressed Concrete Associations of Europe, they took this issue very seriously. A symposium was called in 2001, inviting different countries from UK, France, US, Japan, and so on. They discuss and share lesson learned, problem identified, and they published a FIB Bulletin 15 on durability of post-tensioning tendons. And in parallel to UK's TR47, Bulletin 20 was published in 2002, also highlight the importance of grouting of tendon pre-stressing structure. And then a more comprehensive publication was issued in 2005 in FIB 33 on durability of post-tensioning system. And again, emphasizing on the design concept of durabilities, as well as material construction related to pre-stressing system, protective covering, and also grouting. And then emphasize the importance of maintenance, assessment, and rehabilitation. And these specification guidelines just continue to improve, right? So it doesn't stop there. So every countries, in terms of our international committee, continue to look into this issue. So subsequent publications were made in 2014 on polymer duct or plastic duct for post-tensioning. There's a comprehensive state-of-the-art technology release in 2020 on external tendons. And then further in 2023, which is last year, FIB published a very well documented guideline on management of post-tensioning system, or post-tensioning bridges. Over in the US, similar thing happens around 1999. I think this is probably a time where bridge inspection was taken more seriously, right? So many things happened on different bridges. Niles Bridge, which is built in 1983, they found one ruptured tendon in 1999. Mid-Bay Bridge was one of quite a famous case with a lot of publications. One ruptured tendons found in 2000, leading to replacement of 11 external tendons. More serious problem was found in Sunshine Skyway on vertical tendons of pre-stressing. So the state of Florida, the Florida DOT, started to a comprehensive statewide investigations, which led to a publication in 2002 called New Direction to Florida Post-Tensioning Bridges. It consists of 10 volumes, right? And there were major changes in terms of concept, practice, design of post-tensioning, detailing, design strategy, grouting material, procedural requirements, and so on. So some specific requirements such as shop drawing showing correct duct connections, grout ports, vent detailing, and the use of permanent grout caps. More highlights on grouting material, very strict testing requirement on bleeding, sedimentation, fluidity tests before and during grouting, and also a requirement to do a full-size grout mock-up, right? So you want to do a trial simulating the actual condition of the bridge before you do it. You have to prove to the owner, you have to prove to the supervising consultant that within this actual condition, you're able to perform the grouting work properly. And the replaceability of external tendons was emphasized. In other states, Virginia, Minnesota, South Carolina, California, Texas, they all found varying degrees of the problem, right? So it's not about, you know, US being advanced countries and so on. Advanced meaning you find problem in advance, right? So being the US National Guideline Post-Tensioning Institute, they publish also a series of new specification related to grouting of post-tensioning structure. Again, updated in 2013, 2020. Federal Highway also started many investigation reports, research study, and then they published guideline for sampling, assessment, restoration of defective grouting bridges, and then a very well documented publication on replaceable grouted external post-tensionings, and then further in 2022, another comprehensive publication on durability and maintenance strategies. So these are all well-published documents, and I think it's good for the Asian countries to start looking at this issue more seriously, and there's a lot of reference that we can look and learn. Now, closer to Asia, Japan was one of the earliest countries in Asia to identify this problem. Excuse me. So an investigation in late 1990 of about 120 bridges, they found significant issues, right? So a survey or investigation of the bridges, they found only about 70 to 80% of bridge had proper grouting, okay? And the classification was done on these problem bridges, and you can see corrosion of the cable, failure cable, contributing to insufficient grout or chloride attack was well documented. So Japan also being quite advanced in terms of thinking and improving, they started responsibility to look at new construction manual. The Pre-Stressed Concrete Contractor Association revised their manual 6 times just to improve the guidelines and practices. Also the design and construction guideline published by Pre-Stressed Concrete Institution, published in 2005 and again in 2012. So the publication mainly focused on non-bleeding flowability of the grout, and also emphasized on the grout location, permanent caps, replaceability, and inspectability of these external tendons. They first tried to use transparent duct. It seems like a really good idea because once you have the transparent duct, you see the problems, right? So they started to use this, and what they found was you get to see the problem and you realize you cannot grout these properly. So Japan very quickly did away with this. So by late 1990, a new material was introduced, epoxy-coated strands. And a lot of you have walked into the seminar before. We see there's some samples in front of you. And instead of rewriting specification, demanding a very strict testing protocol, or demanding the supervisors to really force the contractor, specialist, subcontractor to perform the grouting properly, Japan simply got rid of it, okay? So by 2004, grouting is only permitted on straight tendons for internal tendons, and only epoxy-coated is permitted for external tendon. So you can see by beginning of 2000, there was substantial structures in Japan using only epoxy-coated. And these epoxy-coateds are not within the HDP, it's fully exposed. And these strands have excellent durability performance. You can see after 1,000 hours of salt fog test, it has 0 corrosion. Okay, so it's been used for a lot of bridges. It's the standard in Japan. And I will talk a little bit more about epoxy-coated strands at the end of this presentation. Let me finish looking at different countries. So Hong Kong, before it was not an issue. There has been a lot of bridges constructed until 2019. During a routine inspection, they found 1 tendon rupture on the Shenzhen Bay Bridge. And the bridge is only open to traffic in 2007. So suspicion of poor grouting practice, this is what happened when they took it out, okay? So left large area of air pockets behind the anchorage zones, and Hong Kong started a whole island-wide of investigation on external tendons, and they started to improve, again, same as other countries, grouting practices, design specifications, and now they're considering PL3 internal, external tendon, which I will address a little later, as well as considering a non-grouted solution. In Korea, same. Problem was found, ruptured tendons, severe corrosions, and there has been ongoing replacements since 2016. So not every countries are open to share their bad experiences. I think normally Europe, US are very open to this, so you've seen a lot of publications. But because it's not published, it doesn't mean that the problem isn't there, right? So I think a lot of Asian countries, including Taiwan, where I was born and working at the moment, we have the same problem. The owner chose not to see this, okay? So it's an issue I would like, maybe it's time for Thailand to start thinking about this. So what is the problem with these voids and durability? So we start looking at, first of all, cement grout, okay? So cement grout obviously is the most important protective system in the pre-stressing tendon, right? So with the correct water-cement ratio, with the appropriate additive, we are supposed to create a nice alkaline environment which passivates the steel surface, prevents corrosion from developing. But what happens, as you see in many incidents in different countries, there's very often find incomplete filling of tendons, okay? Now in the ducts, when you don't fill the tendons properly, then you have large area voids, leaving behind, exposing to oxygens, to moistures, and leads to corrosions of tendons, and in some cases, severe failure of the tendons. So before we look in a little bit more on durability, let's look at what is in the cement grout mixture. It's actually quite simple. It's just cement, water, and mixture, right? But if you look at the correct specifications, first of all, cement, you should use only Portland type 1. And very importantly, you need to check the content of these cement to make sure they have a minimum or even nothing on chloride and sulfate, which I think Professor Chokhom-Prai already stated that is a very important element that cause durability of the concrete. With a blame value of 300 square meter per kg, right? So blame value is related to the surface area. So you need to have a fine grains of cement. So when you mix the grout, it creates, let's say, minimum lump and also a better flowability. Water you use should be drinking water. We use nice water for beers and coffee. We should also use the same for cement grout. No organic materials are allowed, and you should have also, again, very minimum content of these poor material that could affect a mixture. We use different kinds of mixture. I think there's commercial mixture available to buy. Normally it's used for improved water reduction, flowability, setting time, bleed control, volume control, but very importantly to remember no expansion agent is allowed. And besides mixing, you should have requirement for laboratory field testing with mock-up trials, as I mentioned before, to reflect the actual conditions of the bridge. What are the tests? Setting time, grout strength, permeability, volume change, pumpability, flowability, and so on. I will not get into these tests individually because, I mean, this topic, if you want to talk about it, it will take hours and hours. I think in the future, if there's certain more interest from the clients, we can discuss a little bit more on what is the proper specification. But the question is, what is the current practice in Thailand? I don't know. Maybe you can tell me. I come to Thailand a lot, but it's, I cannot read Thai specifications. I think we all know it's cement plus water plus mixture, but are these specific requirements being followed in Thailand? So let's look at the way or how these voids are created during grouting practice. So this is a very interesting illustration. You understand what grout is not like water. It's a little thick, right? So it flows slightly different. And normally when you have a tendon curvature like this, so for example, internal tendons of continuous tendons within the pre-stressing web, okay? So the grout flows downwards like this, and then it fills up very quickly, and this is what happened when you, at the high point or curvature, you leave behind an air trap. And if you look at, with borescope, if lucky, you might have grout fill, let's say, covering the strand without being exposed. If you're not lucky, then your strands is exposed without grout covering. And if you're really unlucky, then you will find strands of very corroded condition. So this is related to how you do grouting. Okay, so it's not just about mixing, pumping. It's also related to, as I said in previous specification, a lot of emphasis is placed on design and placing of grout inlets, grout outlets, and the sequence and how you grout. Okay, so this is just an example of cantilever tendon for balanced cantilever bridge or precast segmental. So you always want to grout from the lower point, going higher and higher, and then you should have grout outlets, let's say in between 15 and 30 meters. And once the grout is pumped and it comes out of the mid inlet outlet, then you should observe the outlets to make sure there is sufficient quality of grout coming out. Okay, then you shut it off, then you continue to pump until the next high point. Then you observe sufficient grout quality coming out. and then you shut it off. And then you're supposed to keep the pressure for a little while to make sure the grout is continuing to pump until it's really, really full. Then you stop for a while. And this is something that I'm sure nobody does. You're supposed to go back and open all these vents to check again after setting, right? For reasons I will discuss later, bleeding, segregations, leaving to voids. So you're supposed to recheck this, and if necessary, you have to refill it, right? And I think the takeaway today is you have to be aware of that these could cause corrosion, and this could cause impact to the design life of the bridge, okay? So grouting procedure itself is already very important. Unfortunately, a lot of time we're under pressure by the general contractor, by the owner. Finish this in 5 days, finish in 6 days, and we just run and run. We understand, every owner in the world is like this, but in reality, and this is also the cause of all these problems that we've found globally. So grouting procedure, very important. For an external tendon, same. You should grout from low point, going up, and you check different points at different height to make sure that grout's coming out properly. Then you do a seal of the system, you keep the pressure for a while, then you recheck, and then you regrout if necessary, right? So it's just an illustration of how things should be done properly. Now what happened if it's not done properly? So I had quite a fortunate or unfortunate case. In 2019 in Taiwan, we had a collapse of an arch bridge. It's called Nanfang Ao Bridge. I'm not very sure whether there was news to see in Thailand, but it was a failure of stay cable. So the whole arch bridge came down and 6 people were killed. And obviously that started a whole awareness of the owner. And from our perspective, this is the last cause we want to see, right? For the owner to start to be aware of this, was the loss of life. But the focus is not on the main bridge. Actually, during the demolitions of the approach bridge, I actually went to see the approach bridge, how they was taking down segment, because it gave a very rare chance for us to see a post-tensioning system after 23 years. And you can see the lower part of the tendons are actually in quite a good condition. But when you look at the high end of the web, you will see there are voids and corrosion. If you look at closely, they're so corroded that you can just pull it out. And some of the strands are dust, not even strand anymore. And what's really interesting is you look at the corrosion, not only the strands, but the metal duct around. It's so corroded, it's causing cracks in the concrete, okay? So cracks in concrete not only coming from external impact, but it could also caused by it internally, right? So this is some understanding for you what happens when you don't grout properly. So why these things happen? I want to explain the concept of segregation and bleeding. So according to FIP 20, the bleeding requirement of water from air after 3 hours keeping on rest has to be less than 0.3%, okay? And then when it comes to sedimentation, this means that after the bleeding occurs, the top portion and the bottom portion, the density of these grouts should not exceed, the difference should not exceed 5%. But in reality, this is very difficult to do. Let me illustrate what a bleeding is. So you can see this is a test, what we call the incline bleeding test, where a tube is placed with a strand inside, and then some grout mix we put in, okay? So let me highlight this a little bit. So you can see this is the duct itself, transparent duct. This part is the grout. This part becomes water, okay? And this is what happened when the grout mix is not done properly, and you have a segregation which leads to bleeding. So from a research, you can see that once this happens, the strand actually starts to corrode in 2 months. Okay, so in a lot of cases, you can say the owner actually has taken over a bridge where the pre-stressing tendon have already corroded for several, maybe 1 year, 2 years, okay? So it is a serious issue. So what does it mean by, how does this come from? So if the grout is not mixed properly or designed is not properly, a mixture is incorrect, Then you start with a grout in the duct, then you have the fresh grout with the light matters and heavy matters start to separate. And slowly you get the water surfacing on the top, and then you have a sort of medium transition of chalky grout, right? Too high of a water contents, not very solid grout, and in the end you will have a void on the top. Well, first you have water, which then translate to immediate corrosions of the strands. And then you have a void with some poor grout, and this is what happens, okay? So this I just want to highlight the concept of segregation and bleeding. And what does this 0.3% mean, okay? Is it enough, okay? It's actually a very difficult target to achieve, all right? But I'll give you an illustration. So this is a very typical tendon, 2 spans, precast segmental maybe, each span 37.5 meters, so total this continuous tendon is 75 meter. 19 strands, we will use in inner diameter 100 millimeter duct. So this is the theoretical duct volume minus the strand volume. So you get, we should use this much grout to fill. But then you take the allowable 3% of that, you come out with about 1.16 liter of water, allowable by the specifications. And how much is that water? Actually, if you look at, let's say, a typical anchorage system, if the bleeding is, let's say, dispersed along the duct, then we have small area, that's fine. But it gets concentrated once you grout, in one direction, and in the end, the bleeding all comes into a location in the anchorage zone, then this is the volume you'll see, right? And very often you will see the same case as what we see before. It gets exposed like this. And if you take that 1 liter, if you look in the 1 meter long 100 millimeter duct, this is approximately the area, right? So it's quite difficult to fill this. But unfortunately, this is a very important factor to remember. So PTI actually changed that, right? They don't even allow 0.3. Since 2012, they strictly require 0. Okay? So what does 0 means? 0 means like this, right? So in the Wickett induced bleeding test, this is what you need to have. You're not allowed to have any volume changes. How much grout you pump in, it should stay like this. It should have no water coming out. So in summary, incomplete filling of the duct can cause by air trap. It can improper grout mix, a lack of quality control can lead to excessive bleeding, segregations, and bleeding water and voids lead to breach of protective system. Creates a corrosive environment for highly sensitive pre-stressing strands. Durability issues are often undetected during the structure's service until something bad happens. Additionally, I want to share 2 practices which I think I have observed in Thailand, which will further compound to the problem of strand corrosion. First is flushing water. As I understand, this is quite common in Asia. Before you grout, you want to clean the duct by flushing water, right? So you want to wash away the rust band on the strands or any dirt that you have been inside the duct. This practice has been stopped by FIB since 2002, okay? You're supposed to clean the strand before you insert it, not clean it after you insert it. So what happens when you flush the water? You blow it out at the end, but how many of us are very confident that we actually blow all the water out, right? So in fact, you have water remaining, which dilutes the grout mixture, and it's already very difficult to meet the 0.3% bleeding requirement, but you're adding more water into it, okay? So that compounds the problem even more. Additionally, water actually will be trapped inside these interstices of the wires with a capillary effect. So what happens is, once you flush the duct, you blow away, and this is what happens. You have water remaining. Then you grout it, and then strands start to corrode from inside. Okay, so this is a very important concept to remember. I'll illustrate it with a real picture. So this is a duct from a mock-up trial. So after the mock-up trial, we cut it up. It looks really nice. It looks completely filled. But if you look very closely, you notice that these, let's say, little spaces, interstices between the strands are not filled due to the nature of how it's built. If you flush it with water, that's what it's going to look like in the future. Okay, so flushing of water is highly not recommended. Second, not using temporary grout or permanent grout caps. So when you do grouting, you're supposed to let it flow into the anchorage area, and using a grout cap, you should let the grout flow through the wedges, filling up the caps. Okay, whether it's permanent or temporary for internal PT, this is what you should do. But what do you normally do? You just hand mix a batch of concrete and just slap it over, seal it up. Okay, so this is a very common mistake by a hand patch cement mortar. And this actually prevents the grout to flow through the interstices of the wedges and keep water moisture away from the anchorage. Okay, here's an illustration as you grout through. If you have a proper grout cap, then you're supposed to push this water through these wedges. Then the grout fills the cap and you push it out. Now, if you stop it there, then the grout will just come over and then the water stays here. And this is what you find when you open the cap or the mortar. Right? So these small practice, let's say, makes the corrosion issue even worse. So what does this do on a structure? Okay, in reality, catastrophic failure is rare. Okay, you don't really hear it. Maybe people don't report it. We've seen it on documents, but it is a rare case because it is quite difficult to collapse a pre-stressed concrete bridge. First of all, probably about 1/3 of the strands need to be ruptured or wire breaks before the tendon itself fails. So let's say you need to lose about 6 strands within 19. Okay. Additionally, typically your span by span precast segment will have 6 or 8 tendons. You will need about 25% or 2 tendons failed before the bridge starts to be in danger. Okay, but it could happen if you don't deal with it in 30, 40 years. And this, the loss of PT serviceability will lead to structural crack and deformations, which maybe you will find on a bridge inspection, but you probably don't associate it into PT. You probably think it's concrete problem, or maybe what the morning professor has said, it becomes contaminations, but it could be coming from the PT, right? So it's something that you don't really realize. And basically, it accelerates the deteriorations and reduces the life of the bridge. So it is an issue. So what should the owners do, or a consultant do? Facing this potential durability problem, first of all, the question you should ask yourself, are you doing proper bridge inspection or maintenance? If so, is the relevant post-tension inspection included in your program? Okay, maybe you don't know this should be done, or you don't know what to do. And this is why you should look into the literature that I referred to, whether it's FIB or FDOT and so on, and really start to build inspection items into your normal maintenance program. So just like your body, as I said earlier, you should do regular inspections, or you do your health checkup, identify the issue earlier. Sooner or later you have to face it, right? And a few years ago I was hesitant to do so, but as I said, once you start to learn more problem around you, then you start to realize you should do it. It's never too late to start inspection or maintenance before catastrophic things happen. So what can you do? So let's look at inspection. Unfortunately, internal tendons are very difficult to inspect, right? It's embedded in concrete. You cannot really see it, right? So there's really no proven economical inspection methods. There are some technology in the process, okay? So before you talk about inspection, I think I want to emphasize that's why correct grouting and mixture and the placement is important, because it's very difficult to inspect. So better do it right from the beginning. So there are some ground penetration radar with enhanced imaging, that allows you to identify the tendons on a web or even voids conditions, okay? There's also a different technology related to impact echo, also with enhanced image that can do this. But once you identify this, you have no other choice but to break it up, right? So destructive investigation for internal tendons are always required. For external tendons, a little easier because you can do some routine inspection by tapping, or you can just kick it like this. I don't play the sound, but you can hear a very distinct difference in terms of grout filling or empty duct. Or once you identify it, you put a little hole, you drill a little hole and put a borescope inside, okay? But in general, a tapping method, visual inspection measure is enough for you to identify something very early. So besides hollowness or sound, you want to look at the connections of the HDP and the steel duct. You want to look at the HDP itself, whether there's cracks, okay? So these are very, very simple things to do, and the owner just have to make sure that the normal maintenance contractor or inspector are doing it and record it properly. There are additional technology. We are developing some at the moment. For example, robotic magnetic inductions, and we have used it extensively for stay cable, which Jacob will share a little later. You can use it also to check for severe corrosion or wire break existing in the tendons, or there is another technology called capacitance tomography to map actually the void inside, okay? So these all just to help you to identify problems, okay? There's also some technology, mostly in research stage, what they call a guided wave ultrasonic, which allows some penetration through a grouted section, but normally it's in the range of 30 to 50 centimeters behind. But it gives you a quick look on what's behind the anchorage itself. So there are methods that you can use. So what happens when after you do the inspection, you find problems, okay? As I said, unfortunately for internal tendon, there's not much you can do. You have to do destructive testing, and then you have to drill the holes, expose the defect, looking at whether voids or even corroded strands. You should clean it properly, and you do vacuum grouting assisted regrouting. So these are some of the pictures that we have done in the US on several projects. And the idea is to regrout is just reinstate the alkaline environments to make sure that further deterioration doesn't happen. So another thing is on the pour backs or the cement patches. So the US, what the US is doing now is they're removing these, because I've shown you already that what could happen if you don't do it properly. You remove it. Some clients or some owners, they use a special resin to what they call impregnations to pump into the wedge area for corrosion inhibitions, and then replace it with permanent grout. Right? This is the proper way to protect your anchorages. Now for external tendons, if you find a crack or damaged HDP, but the grout is quite sufficient, then you just repair the HDP. There are handheld devices that we can use to repair this. Please don't use duct tape. This is really bad, and it doesn't give you a proper watertight sealness. And then if you have connection like this where you see a separations, you do a nice heat shrink sleeve, which allows you to refix it properly. So there are very easy thing to do, right? Just to patch things up if you can find it, if you spend the time to find it and address it. Now, if you identify the voids on the HDP duct, you open it and you see this, then there is some problem, okay? Obviously, you need to start to engage material experts to decide the extent of the corrosion, whether it's acceptable or not. If it's deemed acceptable, then you have to clean it properly, and then you have to regrout it properly with a connection like this, right? Half-shelled HDP, vacuum assisted grouting, heat shrink sleeve to let's say, put it back where its original condition as good as possible. Now, if it's already corroded or wire breaks, then you have no choice but to replace it, okay? So let's talk about replacement of tendons. If it's replaceable, Okay, so first thing you might have to ask, currently in Thailand, are your external tendons designed to be replaceable? Okay, if it's replaceable, let's say DiviDeck or even our competitor, VSL Fresnay, they all have quite good technology on how to de-stress these. And obviously it's very, very dangerous to de-stress this because there's such large forces. So it has to be performed by specialists in a very controlled and safe manner. Okay, so you always need to engage specialists for this. If it's not replaceable, then you have no choice. You still have to cut it because you don't know, someday this will be rupture, and then you have to install new external pre-stressing. So obviously installing new external pre-stressing tendon is very costly. It's much better if you already design the external tendon to be replaceable. Okay. So this is why I want to look at some of the design and specification recommendation that you can do in Thailand. First of all, I emphasized this several times already, improve grouting material, improve testings, improve your vent detail designs according to correct specification, whether it's FIB, PTI, British Code 445, 446, 447s. Please incorporate inspection of pre-stressing tendon as part of your normal maintenance program. Adopts PL1, PL2, PL3 pre-stressing tendon, which I will explain in the next slides. Try to design replaceable tendons, right? Otherwise, if you have problems, you want to install new external tendon, it becomes very costly, very difficult. Or alternatively, you can look at what Japan is doing using a non-grouted solution, such as epoxy-coated strands. So there are many literature that you can refer to, and I really encourage that the owner and the consultant to look at these very carefully. So first, improve grouting. I mentioned this, I just reiterate again. Proper temporary caps, proper permanent caps, a set of testing that you should do before the grouting, during grouting, and even after grouting, such as rechecking. Okay, so write that into your specifications as your consultant supervisor to enforce it. Inspections. So this is a very good reference to look at FIB 110, which was published last year. A management of post-finishing system. So I think these, if you're a bridge owner, you should know this. It's very common. You have a routine inspection, detailed inspection, special inspection. So you should incorporate the pre-stressing part into this. So for example, routine inspection, just ask your supervisor or your consultant, walk through the visual inspection, look for cracks, spalls, corrosion stains, which are signs of pre-stressing problems, amongst others. You can do tapping along external tendons, very easy to do. If you find problem, or you can select some to open the cap, but you can only do this on external if you have a cap. Okay. Now, if you find voids, then you have to put this under special inspection. Then you need to either use equipment-assisted inspections, such as ground penetration radars, or for external tendons, you have magnetic inductions, capacitance tests, or impact echo, and so on. Then some destructive drilling is necessary, right? So you should regularly put this into your maintenance program and carry this out. So it's important to understand where these things are coming from, right? So I think the Professor Chakrapong already explained the durability of concrete. And once you have durability of concrete, obviously it's very easy for external element to seep through different location of cracks from the drains into pre-stressing area, whether you have the construction joints. So these on the 33, it lists many things that could happen to impact the durability of the pre-stressing tendon. So from a designer point of view, then you should address these issues correctly. So for example, correct waterproof membranes, correct drainage detail, things that you need to consider to make sure that if something happens, external elements does not come into the pre-stressing system. So what is PL1, PL2, PL3? This is basically protection level 1, 2, and 3. So I think in Thailand, you only have one type of tendon, right? There's only PL1. But you're supposed to select the type of tendon according to different environment exposure and different structural protection layer that you have. So what is PL1? PL1 is a very standard duct filling material, consists of, for example, corrugated metal duct with a proper grout according to the spec I mentioned already. PL2 is a PL1 material, but in a complete enclosure, right? So that means full encapsulations. You want a watertight, impermeable envelope over the entire tendon to offer durability protections. You should test these against leakness by air pressure, not water test, okay? In accordance to relevant specifications, and you should always think replaceable design. Now, some clients want to monitor their pre-stressing tendon. So this comes with PL3, which is a PL2 encapsulated system with reproducible measurements. That means continuous monitoring. So you can do it several options. Most common way is electrically isolated tendon, or we call EIT, which basically allows you to monitor the current that produces when you have corrosion that occurs. So it's a very good indications. Or you can do acoustic monitoring to check for wire break, or force monitoring to look at the development of the pre-stressing forces. So this is what a replaceable and a PL3 monitorable system look like. So different from the normal pre-stressing tendon you probably have seen in Thailand, it has two trumpets, all right? So out of the embedded casting, you have an outer trumpet that connects to the bearing pipes or the deviator. Then you have an inner trumpet that runs inside along and connects with the HDB pipe. So the blue part with the anchorage gives you the full encapsulations, and either you have a electrical isolation plate which creates the EIT system, or you can have monitoring system like what we offer, Dynaforce, inside to give you the monitoring capability. So this is the illustrations of replaceable PL3 system, which significantly improve the durability, improves the quality, and reduce the risk of durability. So here's a little closer look at the internal PL3 system and an external PL3 system. And I'm running out of time, so I'll do quickly now. So another options, which is also we want to highlight, is the use of non-grouted system, right? So you can see a lot of effort, tremendous effort over the last 2 decades has been spent on improving grouting methods, improving technology, but you can also choose what Japan did, forget grouting completely, okay? So this is an example of a non-grouted solution using epoxy-coated strands. As I mentioned earlier, it has been used in Japan since early 2000, over 1,000 structures. It's fully replaceable, it's fully inspectable, and it completely eliminates grouting durability problems. And it's currently now under consideration by the Federal Highway in the US. So when you think about epoxy-coated strand, don't relate that to epoxy-coated rebar. There's two completely different type of epoxy technology. So this is a fully, very special resin type with a coating thickness about 0.6 millimeter. It's produced through a very careful production method that gives you a holiday free, so there's no pinholes in the epoxy coating. And then the interstices between the voids, between the wires are completely filled. It provides a very excellent corrosion protections, and it also needs to subject to very high bending requirement, right? So when you break a strand, you don't, the resin actually elongates and breaks together with the strands. So it's already a very well recognized material. It's published, let's see, specification according to ASTM, ISO, Japan, even China is using this very often now, and it's part of the recommendation on the PTI and FIB for state cable. The very first extra dose bridge in the world using epoxy coated was the Odawara Bridge in 1994, and the first non-grouted post-tensioning system, external system using epoxy coated was 1994 in Shutoku Metropolitan Expressway. So we're seeing more and more of this now, especially in marine structure, let's say viaduct near marine structure or highly corrosive. So I'll give you a recent example in India, the Mumbai Trans Harbor Link. All right, so it was, I think it's a bridge of close to 20 kilometer, they also decided to use fully epoxy coated strand. So it's something that's worthwhile to think when you come across, let's say, highly corrosive environments, which you want something to last forever. It has been widely used. DV-DEC has used it first time in 1987 on a Quincy Bridge, state cable bridge in the US. In 1989, a very well-designed bridge, very famous bridge called Alamillo Bridge in Spain. We actually did the inspection a few years ago on this project, and it looks perfectly. It still looks perfect. Several references in US, also in Vietnam, in Sri Lanka. And currently, we're building two very large state cable bridge in the US. One is the Corpus Christi Bridge with 3,200 tons of state cable using epoxy coated strands, as well as Houston Ship Channel using 2,700 tons of epoxy coated strand. So summary, pre-stressing durability. I hope I spent the last 45 minutes emphasizing the lesson learned, and I hope that the awareness will start to come in Thailand. If already not addressing this issue, you should improve grouting method specifications in line with international guidelines. You should incorporate appropriate tendons inspections in your normal inspection programs. And you should, once you identify the problem, you should then repair and improve these tendons to ensure the structure's design service life. Adopt enhanced protective system, consider replaceable or even epoxy coated, I think as a good system. You should install suitable monitoring system in the future for new pre-stressing tendon and structures. I already mentioned a recommendation on non-grouted, for example, as epoxy coated strands. And I think last thing to keep in mind, changing a new system, adopting PL3 epoxy coated, it becomes more expensive, right? But even with an expensive cost of a durable pre-stressing tendon installed properly, it's still cheaper than what the rest of the world has been doing in terms of replacing, in terms of maintenance and regrouting, right? So again, takeaway, I want you to be aware of this issue. I hope that you continue to be curious about these issues. And I hope sooner or later you're like me, you go to the doctor and make your appointment quickly, all right? So thank you very much.